Welcome back to another video. In this one, I'm going to be going through some questions involving the trigonometric functions sine, cosine, and tan. And we're going to be relating this a lot still to the unit circle. And we'll deal with a little bit of exact values as well. Alright, a lot of non-calculator work here. A lot of this is very conceptual. So make sure you refer to your lesson notes too. Let's get started. 18.6. Okay, so we've been given that sine theta is 0.75. We want to find the value of sine pi minus theta. Okay, so let's draw up a unit circle for each of these. Let me get a nice circle going. That'll do. Let's get two of these going. Oh, gotta click on the edge of it. Right. Now let's try to locate this. Could have used the axes, but oh well. Okay, so sine theta equals 0.75. Remember that if we have any point on the unit circle, then the x coordinate will equal cos theta and the y coordinate will equal sine theta, because the radius is 1, because the hypotenuse is 1. So that means sine theta equals 0.75. Alright, that means the y value, or this side of this triangle with an angle of theta right here, alright, is 0.75. Alright, now if we do pi minus theta, alright, so that means if we start at pi and we go anti-clockwise by theta, it's basically going to be the exact same triangle, just with a different orientation. Because look at it this way. Alright, pi minus theta, it's still the same triangle, isn't it? So that means this side of my second triangle here is still 0.75. It hasn't changed. So that means sine pi take theta is still 0.75. Right, and it's positive because we're going in the positive direction of the y-axis. All right, we're going upwards. Okay, let's do B. Now we want cos theta plus pi on 2. So let's see. Okay, so again, let's start with this triangle here, because we're still working with the same one, right? Because we know sine theta equals 0.75. Move in a little bit so it's easier to write. Now we want to locate theta plus pi on 2. So pi on 2 is 90. So how do we do that? Well, theta plus pi on 2 is the same as pi on 2 plus theta. So basically 90 plus theta. So if we start at 90 degrees, which is the y-axis, the positive y-axis, and we go in the positive direction for theta, essentially, what happens is there should be a right angle here, right? Because, let me make that a little bit. There we go. So that'll be a right angle, right? So, hang on. I want to get rid of this. It won't let me. Okay, anyway, maybe I don't get rid of it. And then this angle here would be, wait, no. Oh, this is annoying now. So then this angle all the way around here would be theta plus pi on 2, theta plus 90, right? And then if we, so that means with the positive y-axis, all right, this angle here is theta, all right, which means we can kind of construct our triangle again. Our triangle has kind of just rotated about the origin 90 degrees anti-clockwise. So that means this side here is 0.75. Okay, so let's see what we want. We want cos theta plus pi on 2. Well, it just so happens to be that the x coordinate of this point represents cos theta plus pi on 2, and the x coordinate here would be negative 0.75 because we're going in the negative direction of the x-axis. Alright, and we're done. So that's how we can use the unit circle without a calculator to solve some problems of this type. Okay, let's move on. 18.7. Again, non-calc. Given that cos 140 equals negative 0.766, find cos negative 220. Alright. So cos, okay. So from what we know about the unit circle, cos 140, all right, it's in the second quadrant. So if we draw this, 140 is here. All right, so that means it makes a 40-degree angle with the x-axis, and it's in the second quadrant. So we draw up our cast diagram. That means the value of cos will be negative in the second quadrant, right? So cos 140 is going to equal negative cos 40, right? So that means, and now we can use this to kind of help us out. So since we know that negative cos 40, so now we know that negative cos 40 equals negative 0.766 because here, right? So that means cos 40 equals positive 0.766. Okay, hang on, let me get rid of the 8 there. All right, now let's use this. Now we know what cos 40 is. Now we can actually answer the questions. Well, we'll make it easier. Okay, negative cos 220. Let's find it. So negative means we're going this way. If we go 220 degrees that way, we're going to be here with a 40-degree angle with the x-axis, because if we go around from here to here, it's negative 220 degrees. All right, so that means we have cos negative 220 degrees. Let's write that with an acute angle. All right, if it's in the second quadrant, it's going to be negative. Oh, it's going to be negative cos 40 degrees. Just put degrees back in all these ones. All right, so negative 0.766, okay? And now let's do B. We want cos 400. All right, let's locate 400. Okay, so 400, 360, well, we're going to be here. Okay, so cos 400 degrees equals cos 40 degrees, which equals positive 0.766. All right, so that's how you can use your knowledge of the unit circle and the cast diagram, right, to do that one, all right, without a calculator. Okay, moving on, 18.8. Using the definition of tangent function, show that tan theta plus pi equals tan theta. All right, well, the definition of a tangent, the tangent function is sine over cos, right? So it'll be sine theta plus pi over cos theta plus pi. Okay, now if we have sine theta plus pi, we're in the third quadrant, sine's going to be negative. So it's going to be negative sine, and the angle is just theta, right? Because that's the angle with the x-axis anyway. And then, so if I draw a diagram up, you know, if we have pi plus theta, we're here. That means this angle with the x-axis is theta. In this quadrant, both sine and cos are negative, right? So negative sine theta over negative cos theta. Two negatives make a positive when we divide them, so therefore it equals tan theta. And we're done. All right, let's move on. 18.9. Okay, given that tan 2 pi on 5 equals 3.08, find tan 17 pi on 5. Okay, all right. Let's use the unit circle. So 2 pi on 5, that is, yep, that is, that's the one we're going to use. So let's locate 17 pi on 5 first. 17 pi on 5, so 5 pi on 5 is pi, 10 pi on 5, 17 pi on 5. Okay, so basically there's 3 lots of pi plus 2 pi on 5, so which is here. So we get, so that would be 5 pi on 5, which is pi, and then that would be 10 pi on 5 if we keep going around, and then that would be 15 pi on 5, and finally 17 pi on 5 would end up there. Hopefully that makes sense. So that means this angle with the x-axis is 2 pi on 5. In this quadrant, tan is positive, so tan 17 pi on 5 would have the same value as positive tan 2 pi on 5, which is the same value that we've been given at the start, so 3.08. Now, be negative tan negative 7 pi on 5, while negative 7 pi on 5 would bring us, so negative 5 pi on 5 would be here, and negative 7 pi on 5 would be here, somewhere in the second quadrant, so the angle here would be 2 pi on 5. That means in this, we're in the sine quadrant, so the final value is going to be negative. It's going to be negative tan 2 pi on 5, because that's the angle with the x-axis, and therefore we'll get negative 3.08. Okay, so one positive, one negative, depending on the quadrant that the angle is in. Okay, well, getting there. 18.10. Find the exact value of sine 4 pi on 3. Okay, so this requires you to know your exact values. However you have learned to do that, whether it's just by memorizing the table or drop your exact value triangles, doesn't matter. Alright, but let's get into this one. So 4 pi on 3, well, it helps to draw it first. 4 pi on 3 is going to be in the third quadrant. The angle we're concerned with is pi on 3, the acute angle that we want. So in this quadrant, sine is negative. So sine 4 pi on 3 equals negative of sine pi on 3, which equals negative root 3 on 2. Okay? And that's how you can solve a variety of these kinds of exact value questions. Okay, finally, find the size of the angle theta in the following triangle. Okay, so this one will demonstrate the ambiguous case of the sine rule. All right, so let's set up the sine rule. So remember, since we're trying to find the angle here, so sine of an angle over the opposite side. All right, so sine theta over 18 will equal sine 41 opposite side over 15. Okay, and let's solve this one. So sine theta equals, let's just work this out. So it'll be 18 sine 41 over 15. All right, so theta approximately equals sine inverse or arcsine of 18 sine 41 over 15. So let's just find that first. Give me 1 second to type that through. 18 sine 41 over 15 equals, didn't type it properly. And I need to change calculator mode to degrees because we've been given the angle in degrees. Try again, 18 sine 41 over 15. Okay, 51.9 degrees approximately. Now, remember when you perform this calculation, you could possibly have two answers. All right, so it's going to be 51.9. So this is where you need to, you're not 100% sure, refer back to your class notes. All right, you're going to get 180 minus 51.9 degrees. So this is going to be approximately equal to 51.9 degrees, or was that 128.1 degrees. All right, so what we want to do now is test these and make sure that the angles can add up to 180. So if we have, so we already have an angle of 41 degrees, right? So this one, if we do 41 degrees plus 51.9 degrees, we have 92.9 degrees, which is less than 180, which means our third angle, all right, exists, which means this angle works. And then let's try this one. So if we do 41 degrees plus 128.1 degrees, we approximately get 169.1 degrees. All right, which means our third angle can be a very small one for all three angles to add to 180, which means this angle works as well. So in this situation, we can have two angles for theta. All right, so if I draw this for you, hang on. So we have, so if this if we're going to use 51.9, okay, then it would look something. Well, this diagram already kind of works out, right? Because then this could be 51.9 degrees. But if we were to use this one, okay, we would have, let's say that's 18 centimeters there, 41 degrees there. Oh, but we want this theta here to be 169, which means, okay, which means like, hang on, I know maybe I make that a bit longer, but which means this theta, excuse my drawing, all right, 169.1 degrees, and then we can still get an angle here, which works, right? So that means this, what was the other side? 15 centimeters. Okay, so this is called the ambiguous case of the sine rule, right, where you may have two possible angles that could work for that particular triangle. All right, so make sure that you actually test that the angles actually work out, so they don't exceed 180 degrees. All right, but that's how you approach that particular type of problem. All right, good on you. Thanks for watching, and I'll see you next time.